Let's talk about slope, baby. Let's talk about you. No, I think it was another song. Slope. When we talk about slope, we abbreviate that with the letter M. What's the three-word phrase that pays for talking about slope? Rise over run. Another way that we can describe this is by saying the change in y, so delta y over delta x. Since we are talking about slope, we're talking about change. That means difference, as we've seen in some other formulas. So this is y2 minus y1 over x2 minus x1. That is the formula for slope. Okay, that is our slope formula. That means if I had 2 points, so I have point 5, negative 7, and another point, say, negative 3, positive 3. And I want to find the slope of the line that goes to these 2 points. Okay, can you do that? As we saw in other parts of this class so far, we've seen formulas for distance, formula for midpoint. So you have to know the formulas and plug it in correctly. So we need to make sure first that we label these guys correctly. So let's call this guy x1, y1. Notice I'm using subscripts here. I'm using that to denote the difference between the first and the second x coordinates and the first and the second y coordinates. Now, it doesn't really matter if you call this the first one and this the second one, because what if I'd given you these points in a different order? Wouldn't the slope between those 2 points still be the same? Yes, it should be.
You just have to be the same between the x and the y.
That means you have to go from one point to the other one. You have to keep going in the same direction between them. Yes. So let's write this down. Here's my formula for slope. It's the change in y over the change in x. So let's plug these in here. What's y2?
3.
So we got 3 minus what's y1?
Negative 7.
Be very careful when you substitute things into a formula and use parentheses when appropriate. Not just when you think it's appropriate, when it is appropriate. x2 here is negative 3 minus x1, which equals 5. So what do I have here?
10 over negative 8.
Gives me a positive 10 over negative 8. Now, am I going to leave my answer like this?
Negative 5 over 4.
Right, this equals, when you reduce this, to be a negative 5 over 4. That means if I were to plot this guy, I should be able to clearly see that it has a negative slope. Look, I'm running out of paper here. Let me see, where is mine? Ah, here we go. So far, to take these 2 points that I have, I've got 5 and negative 7. So here's 5, negative 7, and negative 3, positive 3. If I were to look at the line that connects these two, or that goes to these 2 points, can you see that it has a slope that's negative?
Yeah.
Yes. Now I said my slope was negative 5 over 4. Do you all agree? So let's see how that looks. If I were to go down 5 over 4 here. If I go down 5, down 5 and over 4, down 1, 2, 3, 4, 5, and over 1, 2, 3, 4. You see that I'm going to land right back there. So the line that connects these two together does have a slope that is negative. Now, this guy has a slope that's very close to being -1. Down 1 over 1, so -5/4 isn't that far off from it. So that slope, that steepness makes sense to us. Is that okay for you guys?